Tonight we're pleased to have Mike Rivet from Formosa to talk to us a little bit about wastewater management, and we appreciate the good turnout tonight. Mike, thank you for coming.
Yes, sir. To be here and to give you an update about what's happening in Formosa. I've been with Formosa a long time. I know most of you in the room. I've been with Formosa for over 37 years. I started in Bayou Country in Louisiana. I got a plant in Baton Rouge, and then I moved to here. So I've been here about 30 years. And currently the Special Projects Director, what they call me. But we get involved in a lot of different things. So today, what I'd like to do is tell you what are we up to as far as making improvements in stormwater and processed wastewater, because we have a wastewater treatment plant. And so we've done a lot of things there too. So thank you for the opportunity for me to update you on that. So these are some brief slides. Certainly if you have questions, I may answer them. Maybe I cannot answer them. So, but if I can, I'll get back to you. So as I just said, stormwater drainage and some holding ponds, and then processed water and wastewater filtration. Just right. Maybe we're going the wrong way. I'm going the wrong way. It's me. So where do we get our water from? We need water to run our plant. Water comes from rain. That's how we get it. And so how do we get it? Well, Lake Texana, nice picture. You might have taken it, Patrick. Got this from your website. That's a picture of Lake Texana. They pump water to us. And we're very thankful for that. And this is one of the storage ponds on our site that we store that water that is pumped to us from Lake Texana. That's about a 55 million gallon pond right there. Most of the use of that water for us is like the radiator in your car. You know, keep your car from getting too hot. Well, most of the reasons we use water is to control the temperatures. That's the main reason. We have other uses for water. Some of that water is really awesome water. Patrick knows that. It might not look like it when you drive over it sometimes. You say, that's kind of muddy looking, but it's really awesome water. And so we don't have to do much to it. We put a little chlorine in it, maybe, and then we have some clarifiers. We drop the solids out of it. We put it through a sand filter, and that's it. And that's good enough for a cooling tower. But we do make steam too, so we need like pure water for that. So we purify some of the water. And I'm not going to get all into that, but we do. So I want to talk about this stormwater a little bit more, so you can understand some of the terms we use at the plant. So this is just a Google image of one of our units. We have over 20 operating units out there. Some of them, they make various products, right? But the reason for most of this is, let me back up a little bit. I want to make a point of something I forgot to do. Let's see this. Yeah, so you see this right here? Oh, this is important. I'm sorry I skipped over this. Some of these projects have been undertaken in connection with the settlement of a Clean Water Act suit, San Antonio Bay, Hysterian, Waterkeeper versus Formosa. I just want to make sure everybody understands that. That's what we're doing. So back to where I'm just trying to do some basic, so this is one unit. And the reason I want to show you this image to you is that we have some areas in our plants that we curb off around process equipment. And then the yellow lines, or whatever color I picked there, that just outlines the what we call a contact stormwater area. And that's going to be important, and I'll tell you why in just a minute. So that's coming from the rain. So it rains, and some of the water falls in the contact stormwater area, and some of it, and then when it falls in that area, we collect it. I didn't show it on this slide, I'll show it later. We mostly reuse it. TCEQ has given us permission to reuse just about every water you can think of. Well, when we're drought-stricken land most of the time. So this particular water called contact stormwater, they say, you know, you can use it, put it back in your cooling tower in your radiator and use it. That's less water we have to pull from the lake. By the way, the lake is almost 4 feet low, as Patrick knows right now. So we're watching that and still praying for rain. But that contact stormwater is pumped via pipeline by each unit to our wastewater treatment plant. The non-contact, that's the water that's I picked that goofy color, but I was trying to get a contrast for you to show you all the areas outside of that contact stormwater area. To show you that water is gravity flows through ditches. And eventually it's trying to get to the ponds that we're building, and I'm going to show you some really cool aerial photos and stuff in a minute about our progress in building ponds. But so when the rain falls, it creates those two kinds of waters. The contact water and the non-contact water, both of which we'll use that water. Put it back in our radiator, put it back in our cooling water system, because that way we can, again, use less water. So I want to kind of get into that a little bit with you on the stormwater. So this is a pretty good layout. We have 12 watersheds, we call watersheds on our plant. And each of these watersheds have a number, and each of these watersheds lead to an outfall. And these are regulated outfalls by TCEQ. And I just color-coded them so you can see. And all this means you won't go out there and see a wall between them and say, oh, that's a wall between that watershed and the other watershed. No, you know, we just kind of worked with what God did there with the slope, and we sloped it a little bit different so that each of these areas would be designated to a particular main ditch. And so what I've tried to do here is show you with these yellow lines, and it's not very clear, but these yellow lines represent the main ditches. There's a bunch of those side ditches that come into that main ditch, but those are the main ditches, and they carry this water to the ponds that I have shown here. And that's this Cox Creek. So this is Highway 35 and 1593 here, and that's our Gate 8. If you pass by there, you see maybe Gate 8 and Gate 3. I visited with a lot of you at this. This is our admin building. It's right here. So we're going to install one of our improvements that we're going to do for all of these yellow lines. All of these yellow lines represent the main trunk line. And this is an example. This is a photo I got from someone. This is amazing. I think that's based on the size of those men, assuming they're average sized men. I think those are the same size culverts that we're going to put in. I don't know what are these sealers in here. You think 10-foot sealers? Would you say, or 8 or 9 foot?
At least
9, at least 9. So add 3 feet on top of that. That's the inside dimension of these culverts. 12 feet wide, 12 feet tall, inside dimension. So outside dimension, I think, is about 13.5 feet. These are really heavy. In fact, if you ever see one of these on a truck, one of these on a truck, that's about, I think it's 5 feet long. They're just so heavy. But that's what we're going to install in all most of the yellow pathways that you saw. We don't have a contract yet. We hired a design company to design this system. Our consent decree says that I referred to earlier that we need to be able to handle a 6.8 inch in 24-hour rain. That's a pretty good size rain, 6.8 inches in 24 hours. But what we have done is we're going to design it to a 13.9 inch. So essentially doubling. That's why these culverts are so big. Is we decided, let's drain 13.9 inches off of our site so that we don't flood. Double on one with this diffuser, I think is what we call it right now, the diffuser in the back. So I got a couple more on the wrong way. Yes, ma'am. Back on that.
Given all of those filters that you had, and that's really, really good, how many
many violations has Formosa still had going through all that?
We still have some, yes, we still have, so that water, that sampling unit, so it pulls that sample in automatic samplers, really a cool thing, it rotates, pulls the sample, rotates, pulls the sample. But part of it also goes into this net that's got a certain size mesh on it to see, hey, can we catch anything with that net? Which is what it's designed to do. And we have a third-party company that comes out at us to look at that, look at the samples, look at the, and I'm not an expert in this, but I think I'm going to confidently tell you what I do know. And they examine that on a periodic basis to see if they find anything in it. And when they find anything in it, there's a violation associated with that Diane's talking about. And so since we installed that, last summer, I think, last summer-ish. So
329 violations.
329, right, I think that's the number. So, yes, they found things in that net, and things, that means, did they find a sack full of pellets in there? No, but they found what looked like plastic. They're looking for visible plastic. Some of the samples we have to take out of that net are, we have to even take it to a microscope and have a couple of different labs look at it and see, is that plastic? What are these little particles? We need to really understand it. I think we're even going beyond the visible, I don't know what visible plastic is, but we can see, even going beyond that to see, because if it's something, maybe it's something. So let's take a look at it under the microscope. So, and also what happens in that net, it's kind of like, well, I'm going to get to it in a minute. I may repeat myself, I'm sorry. But we took out a big section of the original pipe because we were getting, like Diane said, we were getting really a bunch of instances where there were something in that net and something in the automatic sample. And anytime there's a something, as Diane said, that's a violation. Every time. Every time that happens, it's a violation. So when we cut the old pipe out, and this might happen if you live in an older house, you might see the same thing happen. When you cut the old pipe out, you look inside the pipe and you go, that's kind of, it don't look like what comes out of my faucet, but I see this stuff kind of in there, right? And we all have that. If you cut your pipe open, you'll see that. But even after we replaced that pipe, I'm going to show you that diagram in a minute. We put smooth inside HDPE black pipe. Just took out the old pipe out of service, but that in. We were still finding some of that. We think that same action of building up inside that pipe is happening in the net too. So agglomeration is the big fancy word for it. I guess you can Google it. Agglomeration happens in the net. Organic matter, different things happen. And so when the monitor, who do we call those people that look at that net? Okay, the monitor. When the monitors look at that net, they examine everything in it. And what happens is, if something's in it, even if small, then something else will stick to it, and something else will stick to it, and something else will stick to it. So when everything's said and done, there may be enough evidence there, maybe even from the microscope, that says, that looks like plastic. If it is,
What
it's,
percent of the, are you checking? What percent of the discharge is being monitored? Like 3%.
I don't know how many times it samples, but based on what I told you guys about Dr. Sanchez's design, when it pulls the sample, it's pulling from the top, which is good. It's not pulling, it's pushing that water all the way, just pitching a valve off, in simple terms, and backing that water up in the pipe and pulling that sample to make sure it's the top, because if it's plastic, it's going to float in there, usually. But I don't know how many times we sample that. But that little automatic thing, and I think you might have seen it, it turns and turns.
Yeah,
Do you
I
know
think
how-
they say only 3% are they looking at. So of all your waste stream, they're only looking at 3%.
3% sample times, yes. So of all the time, you're right. Of the 100% of the time that the water's going through the pipe, how many times is that sample pulled? That's what you're asking, right? I need to find out exactly what that is. But I have more to that story that I'm gonna add to in a minute, but I'll get back to you.
It sounds like your design is aiming to catch the most concentrated
Portion of the
strata
stream
of
is
that
flowing.
stream where the plastic.
It is
might be.
true, it is true. Now, since that UF system, we put in CWTP, sorry, in the wastewater treatment plant in May, since then, and I'm gonna show you some examples, things have improved a lot, but even as late as September 1st, I think we found something in that waste. Now, what's interesting is we're finding it in the net, but not in the automatic sampler as much. Since we put the UF, the ultrafiltration in, we're not seeing as much in that auto sampler, but we're still seeing it in that net. But I'll get back to you on that somehow, Diane, on the timing of it. But thank you for asking that. I wish I had the answer for you.
Can I ask a
Sorry, I
question?
don't. Yeah.
So in your treatment system, do y'all inject any type of polymers or anything into the treatment system?
Oh, so there's a whole lot more treatment than ultrafiltration that goes on in this plant. And that could be a session all by itself, because we have biological treatment and we have physical treatment. So there's a lot going on in the wastewater treatment plant, besides just this filtration that's going
Oh,
on.
just
So we got
what about-
clarifiers. In fact, we have clarifiers, much like we have on your water coming in to drop out, and we have three clarifiers. Sorry
What
about
about
that.
solids?
We have four trains. One of those is dedicated to completely recycle. So we get one of those, clean it up, just send it right back in, and put it back in the system. And use it again. But I'm sorry, what?
No, I was just wondering about coagulation. Are y'all doing any type of coagulation on the?
We dropping out solids, yeah, and we have some, there's a solid material that's a byproduct in that plant right now. Has always been. A lot of times you'll hear plants called, plants like ours, zero liquid discharge plants. And they say zero liquid discharge as opposed to saying liquid discharge, because you're gonna have solids. If you're doing your water right, you're gonna have solids. And so you're gonna look at that solid cake that you just created, and what are you gonna do with that? It's gonna have to leave the plant probably. So you can't say zero discharge, because you can't discount that. Zero liquid discharge, you can say, we can't say that now, but I will tell you this. I think it's safe to say that that's on the horizon for us. We think that's something worth pursuing. You're right.
Mike, two questions. Do you sample that stream for VOCs?
No. Just plastics.
Is there a stream that goes into the bay? That's the only stream you have going into the bay,
That
right?
VOC stuff, okay, the water treatment plant, I keep wanting to put combined in there, but that water treatment plant actually has an air permit. Because there's a lot of waters that go there, right, that I just described, that could have VOC, you have to watch that. But that's another whole part of the operation of the water treatment plant, which I'm not an expert on, but I mean, if you ever want that to be a topic here about what all goes on in the water treatment plant, it's fascinating really what goes on in the water treatment, because they handle sanitary, they handle all the waters that all the different units are pumping to them. And so they do a lot of things with it that I can't really.
Do those streams wind up going to the Locker Bay?
Oh, yeah. Everything that's treated, Raymond, in this plant
Yeah.
is going in this path. Except for what we recycle back, okay? But once it's treated, we say we treated it, it's going to the bay. It's eventually going to go through this pipeline conveyance system until it reaches that spot in the bay.
Well, my other question, Mike, was, that's a huge amount of water. And what is it that makes that water not suitable for you guys to
Salt.
reuse again?
Salt. So I'm going to show you a container in a minute, because we put that ultrafiltration system in May. And I'm going to show you the water. It's going to look like a glass of drinking water. It's not, okay? It's salty. It's just a bump under the salinity of the bay. I mean, we got to be careful with it. There's a lot of parameters that we have to monitor, measure, copper content and all kinds of things, temperature, but it's salt water. salty water that's going to the bay. But we have all kind of parameters we have to check. But this, our consent decree that we have, the settlement agreement, talks about capital P plastics. And so really, even though I'm talking about it, I can say, well, I'm talking about a recycle project. Yeah, I can say that as far as the stormwater goes. But really, it's really about what Diane said. It's really about keeping, don't let that water go to the creek, and don't let that water go to the bay with plastics in it. Now, the stormwater part, those are big giant ponds. I'm going to show you more in a minute. This part, this water treatment plant, well, it's going. It's going to the tune of 6.5 to 7 million gallons a day. Which is right to your point, Diane, how many times you sample that? You got 7 million gallons a day going. Okay, so how many times? I will get back to you.
How much water is going? What's the discharge rate?
Oh, it's about 6.5 to 7 million gallons a day are going to the bay after it's treated.
Hey, Mike.
Yeah, yes.
What if we put that back in Patrick's Lake up there?
No, we want it. We want it. We're going to use it. Good question. So I just, in a previous slide, I said currently with our pumping station, we're going to put another pumping station in. That raw water pond that Pat's team is pumping to, well, our pumping stations from those ponds I showed you are going to those same ponds and putting it back in our system at a rate of about 10.6 thousand GPM. But we use between 18 and 20,000 currently. We could use more than that. 18 to 20,000 GPM. Gallons per minute. That's what we use on a daily basis if everything's running good. You know, if we have all of our, we don't have all of our units up right now, but if we have all up, it's probably closer to 25,000 GPM, gallons per minute every day.
So has the discharge rate changed over time?
I don't think so, man. I don't think, has it gone up a little? Over the year. It's gone up. I remember 6 being there for a long, long time, but what's our permit? We're limited 9?
9.5.
9.5.
9.5.
9.5 is our permit limit. It's a state TCQ says where you can put this much out. There. Yes, sir.
On all those filters, what cleans the filters?
We have a backwash. A lot of those filters, some of them have socks in them, but a lot of them have backwash capabilities to kind of like you got a pool, you got a sand filter, you backwash it every once in a while.
And that filter, and
That goes back into that doesn't go to the bay, that goes back into the system, it goes back through again. So it has to really, the backwash water can't just go to the bay. It has to go back through the system. Yes, sir. So some of that's going to come back into play, some of these questions in just a minute, but I want to talk about processed wastewater and that contact stormwater I was telling you about. So I already showed you that part, right? That's the recycle. Am I going the wrong way again? I am. No, I'm sorry. So go back to that. So we have this contact, we have stormwater to deal with. And so we have certain little sections that are contact. So what happens to that? Well, this is just a little sample diagram. It might not be exactly this way in every unit, but it's very, very similar to this way. So when we recycle that water, and I apologize for this line, this particular line is not correct, but these are the ponds, and what we're going to do, what we have done already, is all of these ponds are not finished yet. We have about 80 something acres. I can tell you. We have 86 that we completed. We have 86 that we completed, but we still have 64 more acres to build ponds. So some of this, you'll see, like this is what we call, this section is done. This looks like an inverted state of Florida to me, but these are all kind of shaped funny because the creek is shaped that way. So we haven't built this section yet, for example, but we have completed this section, we've completed this section. We have not completed this one, but these are all complete and this one is complete. So our goal is to recycle that water. So we're designing these ponds. The ponds will actually hold all 13.9 inches of that 24-hour retention. And just to give you an idea what that means, when all of our ponds are built, we'll have a little bit over 159 acres of total ponds when it's all said and done. And if we were to store a 13.9-inch rain event in that 159 acres, the water surface elevation would be 17 feet. And it would represent 1 billion gallons of water. Yes, ma'am.
Is it one of the reasons why the ponds are there is so the stormwater with the pellets will go into the creek?
Absolutely. If there would be pellets in that water, it would not get out of the ponds. Yes, ma'am. So, and we went up, and the white lines represent bringing it back into the system. That pond that I showed you earlier is actually this pond that Illinois pumps water to us with. So we're going to simply put water back in those ponds. Yes, Diane, you're right. I mean, the goal is no stormwater gets out. And so when we complete this project, our hope is that we do that for even a 13, I hope we never get a 13.9-inch rain in 24 hours. It's a lot of rain. But I mean, we're in hurricane country, right? I guess it could happen, you know. Even a 6.8 inch is.
We got an 8-inch in our county thing.
So, yeah, it can happen, right? Yes, sir.
The non-contact area, is that like parking lots and buildings and
Yes,
stuff?
yes, sir. The
And the
streets,
other process is where you get the ones that
the
are
small
walking
little areas in
where
the
you're processing.
Yeah, within the process area, those smaller areas within the process area, yes, sir, those are contact. We're still recycling that, putting it back in our cooling tower. But if we ever have a pump leak or some oil leak or whatever kind of thing happens in there, we can send that to the wastewater treatment plant and treat. But normally it looks like every other part of the plant. It's just that we put curves around it so that we could, if we wanted to, catch it. But we do catch it now, but we recycle it. Almost all of it's recycled. But thank you for that question. So, let's see. So we have, the last thing I want to tell you on this slide is in this location and in this location, we have these big pumping stations that can pump the water back to the white boxes that you're on here to store the water. And right now we got a third station we're designing now, but these are the two I'm putting in. These two can pump about 10.6 thousand gallons per minute. Oh, we're on way. So that's the rain. So when rain falls, that's kind of the rain categories. You know, we got a certain category of rain. When it falls we like it to fall in the lake, right, Pat? But when it falls on the plant, it's either going to the ponds or it's going to be recycled or go to the wastewater treatment plant, which is what I want to get into now. So this part is about those waters that go to the wastewater treatment plant and the waters that leave the wastewater treatment plant and go to the plant. I know this is a busy slide, but I tried to distill it down into what we do. So that one example process unit I just gave you, we got over 20, but I showed you that one example overhead. And I'm just calling them production units. And so the production units they may send these types of waters to our wastewater treatment plant. So what I try to do is represent on here that, you know, that processed wastewater. Well, I'll give you an example of processed wastewater. So that pure water I talked about a little bit, you know, we purify some of that water. I mean, it's ultra pure water. Clean it up really good, and we make steam for our power plant, steam generation. But we also use it when we make pellets, which is a large part of what we do, our products. When a pellet is made, it's cut. You know, it's like a big die like this, and if you were able to peek inside, it looks like spaghetti coming out. And there's a cutter on it that's rotating, and it's cutting the spaghetti into little short sections. So that's the pellet. But we use pure water because a lot of our plastics are for medical use. A lot of them are food grade, so we got a lot of tight restrictions around that. So we use pure water to carry those pellets to a dryer. They would dry them and, you know, load and ship it. But any water from that just that process, we have to treat it as processed wastewater. And not to say we can't recycle it, but if we can't recycle it or we use it all up, it does go to the wastewater treatment plant. And Diane, you're familiar with the plant, you might have heard it called our combined water treatment plant. But I'm just calling it wastewater treatment for this. So we have processed wastewater that goes and cooling tower blow down. One of the things that really we do really well, I think. The only reason I say that, I went to a conference in Houston and people were talking about how to conserve water. And so there was the Exxons and the Mobils and the Shells and the Dows and all those people, and they asked the crowd that I was in, how many, so you get this water, you send it through your cooling tower, your big radiator, how many times do you send it through? You feed your tower, it cools the water, it goes to the equipment, gets it to the right temperature you want it to, and it circles back around. You can, if you do it right, you put it back in the cooling tower again, you know how to just discharge it. So making a whole circle like that is called a cycle. So the group asked, the group was polled, how many of you recycle 5 times, at least 5 times? Send that water back through again, don't just get rid of it after one time around. And I was surprised only 3 or 4 people raised their hand. So when they got to 10, hardly anybody. When they got to 15, how many of you send your water 15 times through there? Well, I was the only one that raised my hand. So we really have been working on this for years. So that ultimately though, when you get cooling tower blowdown, it has to go, because it gets concentrated, the minerals in it. So it eventually goes. So we have processed wastewater, I gave you an example, cooling tower blowdown, and that contact stormwater I was telling you about. We send that. What we're in the process of doing different. So let's get to that. So what are we doing different on that? So these waters, and if you remember that slide a while ago, I said that those waters are pumped. It's not a conveyance ditch or anything that brings those waters to the water treatment plants. Right? It's pressure pumped. And so one thing that we've done in a lot of units, but not in all units, is we're putting filter systems on all of those, you know, the last chance before it leaves the unit, through a filter system, before it gets to CWTP. Now, wastewater treatment. Now, in our wastewater treatment, maybe in May-ish timeframe, that we installed, completed our installation of an ultrafiltration system. That ultrafiltration system, and that's how fine particles it screens out, 0.0004 millimeters. That's a huge system that we're working with a company called Suez, and we're actually leasing that equipment now. Suez was very helpful for that, because when we really ramped up our pursuit of getting ultrafiltration on all the water in the water treatment plant, Suez had to go all over the world to find that equipment. It just was not in the United States. So now we have a lot of equipment there. But when it leaves the waste, it's destined to go to Lavaca Bay, right? So when the wastewater treatment plant filtration is done, then I call this section, I don't know what to call it, so I call it a pipeline conveyance system. Because eventually when it gets to the discharge in the bay, it's going through a pipe. That's how you get it. Okay? And so I called it a pipeline conveyance system. But in that system, on this path to the bay, there's a mesh screen, there's an inline strainer, we have some big settling tanks that were rented. We put some basket strainers in, we put several bag filters in, at a series 600, 400 down to 200 millimeters. Eventually gets to the bay. Now I put this on here. I don't plan on spending a whole lot of time on that, but I will tell you that we have what we call a WSM, which is a wastewater sampling mechanism. And I have a few pictures, but it's been by the plant. There's a new building right across from Gate 2 area, kind of over toward Lavaca Bay. You can see a metal building. That's that. And we had that designed by Dr. Jose Sanchez. It's a really cool system. And, you know, most of the products, these plastics, these capital P plastics that we're trying to improve on. Don't let them, and like Diane said, don't let them in the creek, but also don't let them in the bay. Don't let them in the creek, don't let them in the bay. I mean, we gotta guard against that. So this pipe is, what is it, 24 inch or the pipe to the bay? Roughly around there somewhere. Well, it's never really full. In fact, I'm going to show you something in a minute. We replaced a large section of that, but it's never really full, and it's been there since day one. The cool part about that design on the wastewater sampling mechanism is people might say, well, how you know you're getting all that stream? How you know you're getting a true representative sample when your sample system samples? Because it's looking for plastic flake, plastic particles, pellets, whatever, it's pulling samples. It's got an automatic sampler, and it's got also another mechanism where it puts it into a net, catches anything that might be in the net. Well, the way that Dr. Sanchez designed it, which was really pretty cool, is that it builds the system, and I'm not an engineer, I'm not gonna try to act like I'm an engineer. But I'm from the bayou, and we can move water down there pretty good. But they fill the pipe. She designed it where the pipe gets filled, because it's not full, it gets filled so that the system has access to the top of the water. And then it pulls that off. It's really clever design. In the process unit box, those filters have a filter. Some people have installed filters, some people have not installed filters yet, but they're working on it. Everybody's working on it to filter their water before it even gets to the water treatment plant. And so those waters are contact stormwater that I talked about, and I put this little bitty thing there, but just to show you that that's where the filters I talked about are going. And so it can go here, but now that we got permission from TCEQ to recycle that water, don't send it towards the bay, just use it again. Because Pat will tell you, because Pat's got a huge evaporation rate on that bay. Pat can calculate it. Those cooling towers, we're at 25 cooling towers. That's a lot of cooling towers. So you probably notice in the cool weather, you can see the condensation pretty good coming out, but it's always there. That tremendous evaporation. So we lose a lot of water. So it's really advantageous to us too. And Pat, even LNRA is even concerned about our water conservation plan. So he's pretty knowledgeable about our water conservation plan, because I'm his customer, but it's a very important item. So this recycle that TCQ has given us permission to do, that's really benefited us a lot. But you can see that dotted line, we still, if we have to, we'll send it to the water treatment plant. And that's contact stormwater. The other one I mentioned was processed wastewater. So, and it's a real simple diagram. I just wanted to show you that it's pumped. It has to be pumped there. I mean, we're a big site. The only way to get it is pump it in the pipeline, get there. So, but again, I want to feature the filter that a lot of people have already installed that filter for this processed wastewater, but not everybody has, but it's part of our planning and part of our improvement. So what does that look like? Well, that's an example of one that you're going to put in. I mean, it's a pressure system, right? So you're pumping, so you've got pressure in it. That's a water filtration system. And inside of that is, it looks like my grandma's old pressure cooker, but I know it's not. But there's these socks that go inside these filter socks. That kind of what you were talking about a while ago. So eventually you have to change those out or flush them out, because but that's kind of an example I want to show you guys. And another one, and I'm not an expert on this, but this ultrafiltration, which we finally got to in May. We were doing all kinds of other filtration systems, but ultra is like really awesome. But we finally got to that in May. And that's when I was mentioning earlier that auto sampler is hardly seeing anything in there. Just about everything we're seeing, when we see things, then obviously we're always, let's just continue with better, but still happening. Better, but still happening. this being caught in that net. But since May, it's gone down really a lot. So this is, I was trying to get a visual image for you, but I got a couple there. They're okay images, but this is some water. You can kind of see, this is before UF treatment. This is, not UF treated ultrafiltration. This is water that has been treated ultrafiltration. And another view of that is in these beakers. This is when we were doing some sampling prior to, but you can see how really good that water looks. So it really puzzles us sometimes. We've been seeing this ever since May. Can we get familiar with that TZ-T07 place? This is something we have in the plant. It's right after the water treatment plant. And then of course now we have, that's kind of open. And then we have the water, the WSM that I talked about a while ago, that pulls those samples. Since we did the UF system, really the water has been looking like that. But yet there's still something in it. So we're trying to figure that out. Something's happening between, and we're trying to work it out because we really don't want those violations. And even though they're better, they're still happening. So if we go back to the beginning, before UF, yes, there were more things being found in the sampling process. There are less things now, but there's still things. That's a problem. Still things, yes.
Mike, it occurs to me that there's gotta be some other technologies in processing the plastic plants that are dealing with what you're dealing with.
Nobody's having to do this right now. We're the only petrochemical company that I know that's doing all this. The only one
In the nation or
in
worldwide?
the nation, maybe the world.
So you're cutting edge here.
Well, I don't know if we call it cutting edge, but
They had a lawsuit.
we had a lawsuit, like I
They
said in
had
the
a
beginning. We had a lawsuit, right? That's what I said in the very beginning. And so we came to an agreement to solve this problem, right? And so that's what we had to do. So even though I show you this pretty water and this pretty beaker, and it looks like drinking water, but it's salty, right? We're not there yet because we still find stuff in the net. Whether it's that agglomeration I described or something else, regardless, we're still finding stuff. So we still have work to do, but that looks like drinking water. Nobody's got that coming out of their wastewater treatment plant, I promise you. But we know it's still not good enough. Why? Because we're doing all this sampling. So that's what it looks like after UF. Now, yes, we have seen, again, I'm repeating myself, but since that UF system at the wastewater treatment plant, that's what the water looks like. How in the world are we still getting particles, little tiny, it doesn't matter how tiny, by the way. It doesn't have to be that large. It's in that net. It's visible plastic, or maybe even microscopic plastic. That's all it takes. It's a violation. So it's not a lot. It doesn't take a lot to be a violation. So we're trying to get it to nothing. Now the little automatic sampler is doing really good. So what I'm getting at is it's a constant study. But there's a whole team of guys who we got to figure this thing out, kind of thing. Because it's not fun to have a violation. It's not fun to pay them. It's not cool. But so anyway, that's the benefits of the ultrafiltration. So I want to get a little bit on this. I'm almost done. I'm sorry, I'm taking a lot of your time, but this is just another view. I may have showed this earlier, but this is the water treatment plant. This is where the ultrafiltration systems are. We had this black line. It's kind of hard to see, but that represents the original pipeline. So we disconnected that piece, and the yellow line is my attempt. I didn't draw it too straight right there, but that's a new 24-inch HDPE line. There's a smooth inside. You see that black HDPE pipe. Really cool if you weld it smooth inside. And that little box represents that sampling station I was talking about. So even though we put all this brand new pipe in, and we got that ultrafiltration, and it looks, water coming off of this water filtration today, looks just like that beaker did. We do have these, do you see these two little black dots? I made those myself. But they're open air, open tanks. And we tried to, what my thought was on that, it would be kind of like a settling tank. It was just an attempt, but it is open air. It is open air. So we have a sump right outside the last little point. There's a little sump right there, and there's an open there, and then it's open at the WSM. But with all that brand new pipe and with those filtration, we still got work to do. We're constantly working.
So when you put the new piece of pipe in, were you able to verify by sampling effluent that was coming through the old pipe and seeing it dirtier than what was?
Oh, it's
coming out
definitely an
of the new
improvement,
pipe?
but we're not using the old pipe anymore.
Yeah, just wanted to, that verifies that something's coming out of the pipe.
Well, I think, I don't know, maybe I shouldn't even say, but I think since all pipes build up like that, the flow water, even potable water, stuff sticks in that over the years, right? So when we tried to clean things and we probably stirred things up because we're trying to do improvements, and it probably found its way to the WSM. That's some of the reason that it found itself at the sampling station. But when it finds itself at the sampling station, it's a violation. You pay. So that's what we do. And the number Diane quoted a while ago, that's the right number. So that's a picture of that. That's just another picture of the same thing. And I know I kept you a long time, but that's what I wanted to cover today. Just I want to talk about those waters because I've talked about those waters, storm water from LNRA before, and I think, man, I did such a great job. I explained it so well. Well, I should never ask myself if I explained anything well. So Amy and I, last time I gave this, Amy was there, so we asked some people questions about it, and by virtue of answers, I realized that I was not completely successful. And I'm not saying I was today either, but this is different. You first ones I've ever seen the water. I tried to define the waters in a way that you can appreciate the different waters. That the water's going to the ponds and the water's not. But I do have two really cool, if you don't mind. They're like one's a minute long and one's less than a minute long. But it's a drone video that we took of those ponds. Because I can show you what I just showed you there. Okay, yeah, you put some blue boxes in it, that's pretty. But truly, the video I think would help you.
Do you have sedimentation taking place in those ponds now?
Oh, I'm sure.
Stuff settled down?
I'm sure we got dirt. I mean, Pat senses some dirt, and a little bit. And then of course.
He says his lake's filling up, it's like 25% full of sediment.
But I said a little bit down there.
A little bit.
Which one do you
Oh,
want?
I'm sorry. Yeah, can I click it from here, you think?
No.
But I want the first
Well,
one, I guess.
yeah, the first one?
Yes, ma'am. This is a really short one. Okay, this is that's the bay back there. That's Highway 35, real quick. So what we're doing, and this is not a brand new video, okay? This wasn't like today. But that's our pond, one of our ponds, and it's connected to this pond. It's got some pipes that go under there. It's connected to this pond. I can't show all the ponds here. This is another pond right there. But we're on the south side of the plant looking north. There's Cox Creek here. So you can see what Diane was talking about a while ago. This is very close to the creek. And so these berms are about 24 feet tall. That creek, by the way, that's an if for that one. You can go to the next one for me, please. That creek, there's a weir that Alcoa built whenever they built it, and it really created Cox Lake. And the top of that weir, if I'm not mistaken, is at 9 feet or 10 feet. And so it holds back the water. So that's why most of the time when you cross over 35, you'll see some water, because that weir is not that big over the bay. It goes over it when it rains a lot, of course. This is can I stop it with this? Do you know?
I don't think so. I think it's just for PowerPoint. You want to start it over?
No, it's fine, it's fine. But I would like to stop it. Maybe if you could stop it for me right now. I'm so sorry. I didn't know I was going to.
You can actually,
Thank you.
if you want to just.
Oh, yeah, make it. Okay, so I just want to point out a couple of things here for y'all. So this is Lavaca Bay. It's Port Lavaca over there. Is that your light right there, Rivet? Might be. So So this is, remember I talked about that inverted state of Florida on the left side of the screen? This is a portion of that pond. And we'll get it rolling in just a minute, but these are giant pieces of earth moving equipment. I mean, giant pieces. And so this pond's under construction. This pond has since been completed, but we need to add about 60 more acres to this pond. Well, we can't go. This particular pond is different depending. It's different depending on the soil. So we have to do some core samples of the soil, because down there are sands that carry water. It's pretty cool, right? I'm not an expert on anything about it. Just like the creek is flowing on top, there's water flowing through core samples. So some of our ponds we can go deeper than others. And this particular pond is really a good spot to build a pond. We could actually go deeper, but we went to minus 5 feet above sea level. I mean below sea level. 5 feet below sea level. 5 feet below sea level is this particular pond. And when we extend it, we're going to extend it around here. You can kind of see that rail curves. And I'm going to start the video in a minute, but the rail curves around. So this pond kind of ends right here. You'll see it in just a second. We're going to build about 60 more acres here. Because our goal is to have 159 acres when it's all said and done. But some of our other ponds, the ones I showed earlier, they're, the bottom of those ponds are plus 2.
Maximum water surface elevation, you said was 17?
So when the ponds have 13, if it rains a 13.9 rain event, it's a big storm, and our ponds fill up from that event, they're at 24, you notice the berms, right, they kind of build them up a little bit. The top of the berms are 24 feet. But when the water surface elevation from a big rain event, from a 13.9, we modeled it. BHP, a company that we hired, is modeled it, and at the 17th, so the top of the berm is 24. Its range is 23 to 24. When the water surface elevation is at 17 feet, that represents 1 billion gallons of water, which is the equivalent of, close to the equivalent of 13.9 inch storm.
You line the pond?
So right now, great question. So we've been really anxious about building these ponds. We've been building these ponds, but BHP is helping us do the final design on that, because they've been, all these ponds need to be connected properly to function as one big pond. And secondly, we need to make sure we got the proper erosion and lining. So, in fact, I met with them today. They came down and met with our plant because our engineering, our EC Civil Engineering team works with them to talk about the project, as things are happening. So they're probably going to recommend in a final plan, we have to develop a final plan on that yet, but it's probably going to be lined and other things for erosion control purposes. Because like I mentioned the sediment a while ago, you got to maintain these ponds. I mean, we got to maintain them and make sure they function.
And maybe it's going back, I wanted to know the bottom of the weir, what's the elevation on this?
The bottom of the weir.
Yeah, so whatever release, so how, yeah, so if that's usually a release point, so the overflow.
Oh,
So
it's
how deep is
the top of the berm. There's no release point. Now, the release point, you can say that's a release point because we have been for years, we have outfall gate structures. And those are still there. But we keep them closed. So the water now is diverted into those ponds. In the final construction, we may have to elevate those just a little. But the design has never to open them anyway. So the water, the new big culverts I talked about is going to direct the water into those ponds. So it's going to, the gate is not in play. It's just going into the ponds. The pump stations are in play. They bring the water back.
Yeah, I guess the point was just what elevation on.
The berm, the top of the berms are from 23 to 24 feet. Now, we're pretty flat, as we all know. Those of you familiar with the plan know that along Highway 1593, we have our security fence. We have all these gates, 2, 3, 1, 3, 4, 5. That's kind of where the watershed starts, a little bit toward 1593 from that. But there's kind of a point in between our security gate and 1593 where the water goes to 1593 and the rest of it goes destined. God designed it to go to the creek. Okay. From that point all the way to the ponds is, for one watershed where our gate 2 is, 6,700. But the slope is not very much. It's pretty flat. And you need some energy on the front end to push that water down so gravity can work for you. So I think that's in part why these structures are so massive. But they have to be installed in the slope. But once they get down to the end, and by the way, most of our roads are at 18 to 19 to 20 feet, the top, center of the road. But the berms are 23 to 24 feet. So, thank you, sorry. So let's start this, and I'll try to point some things out quick. It's a fairly short video.
Do you want to start over or keep going where we are?
You can start over if you don't mind. That was 10 seconds, you can get that back or whatever it was. So I want y'all to just kind of observe these pieces of equipment. I mean, these are massive pieces of equipment, but they've finished the work here already, but they're digging. And I think that's Rex Cove. And again, just to be clear, we're not finished digging. To get to 159 acres, we have 80-something acres so far. We have more to build. So now we're beginning to swing around, and so we're going to start looking north in a minute. I mean south. We're swinging around to the north. Now this, you can see it right there. There's another pond that we just completed. It's smaller. They're all shaped irregularly. You can see where they're connected here. We need to connect all these ponds. And way over here is where I was showing you earlier. Those ponds I showed you earlier are way to the south, in fact. You can see that's at the port. That's the port right there. That's the port right here. So that's all of our rail, and this is very north part of our plant. So this is really the end of the pond right here, but it's going to extend all the way around. We're going to add 60 more acres, and it will be all at minus 5 feet below sea level. Because when we did our core sampling, we're still in clay. So we're still in clay, so we went that deep. Those other ones that aren't that deep, when we did our core sampling, we were getting sand. So we had to go back up until we had good clay and then stuff. That's where we made the bottom. We wanted to make it all deep, just couldn't do it because it would be impacted by it. We would impact the sand, or the sand would impact us. Probably. It reminded me of Louisiana. You know, I grew up in Louisiana. We had the mighty Mississippi, and it's funny to see. But in the spring of the year, when the mighty Mississippi gets real mighty, you get a mile from the river, and all of a sudden you get this beautiful artesian water flowing up through the sand. You go, oh, isn't that cool? Pressure from the river pushing it. So this area is no different. There's sands that flow certain times of year. But those are two videos. I just kind of wanted to give you an appreciation of the magnitude of what does 159 acres. This is about a 2,000 acre site, roughly. So the 159 acres was kind of a challenge with the configurations that we had. But we were able to go deep on some. So we could go, we have, by the consent decree I told you about, we have to hold 6.8 inch 24-hour length. But since we doubled that rainfall event, we had to really make our ponds huge. And then we had to maintain them. So when we get finished with those ponds, we can't just let them fill up and go, look at that nice full pond, because the next rain event comes, you don't have that capacity, right? So we got to keep pulling it down, put it in our pond, tell Pat to back off a little bit. Don't send us so much now. You can send some later, because it don't rain much. But when it does, we'll be ready for it anyway. So I just want to give you all that update. I appreciate it. I know it took long. I'm sorry about that. Yes, Pat?
So, Y'all can use that water for any purpose.
So the water we get from Pat and the storm pond, holding pond water we put in those we call them Eleanor ponds. They're our ponds, but he pumps water we buy from him into there. That's also our fire water source. So our ERT guys, and we got a fire hydrant system just like any other city. And so when we hook up to that, we want water to come out. So if you look at a pump suction, we have two stations. We have at that pond, at the Illinois pond. We have a station that has the water that brings the water to us so we clean it up and use it, right? The cooling towers, 25 cooling towers. And that pipe, that pump suction pipe goes, let's say I'm standing on the bottom of the sump, or he calls them clear wells because his water's prettier, but it may go down, I mean, I'm not exact on this, but let's say the processed water pump suction goes right here. Well, that's a lot of water between there and there, but for the processed water purposes, that's it. And over here is a fire water pump, and it's also got a suction pipe, but it goes all the way down. So that water from there to here, whatever that is a volume that's reserved. We might not be able to run the plant because we don't have water, but we have fire water.
Can you use that for fire water?
Oh, absolutely. Yes, ma'am.
What do you do with all the pellets that are in there? Are they gone now, or do you have to, do something to get rid of them now, or what?
You know, if there are any pellets in there now, and they may or may not be, I don't know, but they would travel back through the system, so they could be caught in the clarification, dropping out the solids, or caught in the sand filters, because we're gonna reuse that water. So just like the Illinois, since it's going to the Illinois pond, it has to go through all the filtration systems before we can use it in our cooling towers. And after we use it in our cooling towers, it has to go to the wastewater treatment plant. And there we have all that filtration that I told you there. So eventually, the closed loop will be that it's gonna go back through our system again. But we do have people that inspect, and if they see pellets in there, I don't know of any in there now.
Are you talking about the ponds down there by the outfalls?
Yes.
And you're saying there's no pellets in there?
No, I'm not saying there are not pellets in there. I don't know how many pellets there are in there, but if there are pellets in there, we would have to clean them out. Or it would go through our system and get filtered out. But it's not going to the creek. We need to deal with it. We need to definitely deal with it. And so sometimes things happen and we say, oh, that thing happened, but the water's going to be contained in the ponds. Or sometimes it's caught in our filtration systems we already have. We have some in our ditches we currently have, although we're gonna improve our ditches and construct new ditches. We have these conveyor screens that turn constantly so the water flows through those screens and it captures the pellets that are in it and any solid debris that's in it. It puts them in a little hopper. And from the hopper, we put it in another hopper and we resell that. Or we just consider it waste. I'm not really sure. But that's another question. I'm not exactly sure how the guys that operate the ponds, how are they inspecting the ponds, looking at the water in the ponds. But it's gonna be recycled because we're trying to keep humidity all the time. So when we get a level, we're recycling with those pumps back into the pond, back through our filtration system so we can use it again. And then after we use it, it goes to the water treatment plant where it's filtered again before it goes to the lake. Because if we use it in our process, as I described, this is not stormwater now. Now it's water that's in our raw water pond. It's not that stormwater anymore. It was stormwater when it hit his pond, or when it hit our plant, but now that it's in the pond, we're bringing it back into our system, and now it's water that's used up until it's sent to the water treatment plant. And it has to go through all that filtration process before it goes to the lake.